Hi, Mr. Simmons here, and I'm going to go through in this video the kerboodle interactive tasks for topic P9-4 for physics, which was set last week. So, starting with the interactive using graphs, these are just a series of true and false statements to go through. So first one, a tangent is a line drawn at right angles to a graph. So this one is false because a tangent is a line that you draw to follow the curve of the graph with a straight line. The area under a distance time graph equals the velocity. This one is also false. The area under a distance time graph would not actually equal anything that we would particularly calculate. So if we were looking at a velocity time graph, the area would represent distance. So basically they've got these two words, distance and velocity, swapped around. So if you reverse those two words, then that would make the statement true. The steeper the gradient on a distance time graph, the greater the speed. So this one is actually true. The acceleration can be calculated of a velocity from the gradient, of a velocity time graph is true, because acceleration is change in velocity, that's the vertical change, divided by the time taken for that change, which would be the horizontal, the x-axis. So whenever you're dividing the y by the x-axis on a graph in a triangle, you're calculating the gradient. In this case, that would give you acceleration. Velocity has size and direction, that's true. And velocity is the same as speed, that's false, because speed only has size, whereas velocity has size and direction. So in physics they are different quantities. Next part, a cyclist starts off from traffic lights and quickly reaches their top speed. After a few seconds they brake suddenly because a car pulls out in front of them. Which graph best matches the description of the journey? So we're looking for them accelerating to begin with. If they're starting off from traffic lights, so they're stationary, and then they quickly reach their top speed, then that shows that they are accelerating. So the best graph that shows that, you can see this one is distance time, this one is velocity time, this one is distance time. So this one is accelerating, this one is also accelerating, because the curve for distance time is going upwards. For velocity time, we can just see a steady increase in velocity. So both of these show acceleration to begin with. This third one is showing an actual deceleration. So the distance starts off increasing steeply and then gets shallower and comes to a stop. After a few seconds, they brake suddenly because a car pulls out in front of them. So they're then going to stop. Now in terms of velocity time, it says they brake suddenly. So this one, that's a very gradual braking, actually slower than the acceleration to begin with. So this one, the distance suddenly stops changing, therefore that shows the car has come to a sudden stop. So that's the best one to show this. This one shows distance decreasing, which doesn't make any sense at all. So on to the next kerboodle interactive, which was about motion. Use the information provided in the graph to type in the missing words. So the graph shows how, and it's distance, because we can see on the y-axis changes with time, which we can see on the x-axis. The car's speed is calculated from distance divided by time. Remember, the gradient of the line gives us the speed, and that is the distance, the vertical change, divided by the time, the horizontal change. The car accelerates between A and B. We can tell that because the distance time graph, the graph is curving upwards. Number 2, use the information provided in the graph to type in the missing words. Again, this one, however, is showing speed against time instead of distance against time. So the line now means different things. For the first 10 seconds of the journey, the car has uniform acceleration. That is because the speed is increasing steadily as time goes on. The car travels at constant speed of 30 meters per second between 10 and 20 seconds. So here's 10 seconds, here's 20 seconds, and you can see that the velocity or speed has stayed constant at 30 meters per second. The car decelerates between 20 and 25 seconds. So at 20 seconds here, we're going at our top speed of 30 meters per second. and at 25 seconds it's gone down to 0 meters per second, so that decrease in speed there decelerates. The distance travelled is found from the area beneath the graph. So this is, remember, a speed time graph or a velocity time graph, either of those. The area underneath the graph, as we found out last week, is what gives us the distance travelled. A horizontal line shows the car moves at constant speed on a speed time graph. Equations can be used to calculate things to do with the motion of moving vehicles. It is important that you know what the terms mean in these equations. One equation you need for describing motion is v squared minus u squared equals 2 times a times s. Type in what the letters represent in the equation. So v stands for initial velocity. So v in the v squared is final velocity. U stands for initial velocity, so the U there is initial velocity. So we're calculating a change in velocity squared here, with the final velocity take away the initial velocity, both squared. A stands for the acceleration, and then S is the total distance travelled by the car. So the correct symbols for distance is an S, not a D. There is another letter T, which is the time for which a vehicle is been moving. That's not shown in this equation, but it is shown in others. So you need to be aware of the meanings of the terms initial velocity, final velocity, acceleration, and displacement, as well as how they can be determined from graphs. Now, displacement is the vector version of the quantity of distance, which you'll learn more about in this week's work for topic P8.1. As well as how they can be determined from graphs. It is also important to understand that some equations need to be remembered for the exam and will not be provided. These include equations in other areas of the specification, so you need to familiarise yourself with these and know them. So, moving on to the third kerboodle interactive now, which is on math skills for velocity and acceleration. Number 1, the distance time graph shows the journey of a motorbike. Type your answers into the spaces. So remember, this is distance against time. The velocity equals distance divided by time, or the gradient of line AB. So the distance, first of all, if we take the line between A and B, the first 5 hours, so drawing a line up from 5 hours directly between 4 and 6, takes us to B there. If we go across from there to the y-axis, then you can see that the distance it's gone in that time of 5 hours is also 5. So 5 kilometres in 5 hours. So 5 kilometres there, and time 5 hours. So if we divide 5 by 5, distance divided by time, we get 1 kilometre per hour. How far does the motorbike travel from point A to point D? So here is point A, here is point D. So the distance it's gone there we can do by going across from point D, and we can see that from 0 up to 12 on the axis, so it's gone 12 kilometres. What is the velocity of the bike between points D and E? So here is point D, here is point E, and it has stayed constant at that velocity. It stayed constant at that distance of 12 kilometres, meaning therefore that its velocity is 0. If its distance has not changed as time gone on, then it is staying at 0 kilometres per hour. Number 2, complete the sentences using the correct words from the drop-down menu. So the unit of speed is meters per second. Velocity is speed in a given direction. An object travelling at a constant speed travels the same distance each second, producing a sloped line on a distance time graph. The steeper the slope of the line on a distance time graph, the greater the object's speed. So the steeper the slope, the greater the speed, because the speed is the gradient. A flat horizontal line on a velocity time graph, so this is different to the one we were just looking at, shows constant velocity, and a negatively sloping line, so that's a line sloping downwards like that, shows a constant deceleration. Number 3, type your answers in the spaces to answer the questions about this velocity time graph. So notice here we've got velocity time, not distance time. Calculate the acceleration in the first 20 seconds. So the acceleration on a velocity time graph is the gradient. So the first 20 seconds we need how far it's gone up by how far it's gone across. So 40 meters per second divided by 20 seconds, because they're both from 0. So 40 divided by 20 gives you 2 meters per second. 40 divided by 20 gives you 2 meters per second. Acceleration between 20 and 40 seconds at B. So we're now looking along this part of the line between 20 and 40 seconds. So here the line has stayed flat, horizontal, so it has stayed at a constant velocity of 40 meters per second. Calculate the distance travelled in the first 40 seconds. Now notice this is H for higher tier. So this is going back to using the area under the graph to work out the distance travelled. So the area under the graph in section A from 0 to 20 seconds. So this is a triangle. So it's this area here, which we get from half times the base times the height. So half times the base, which is 20 from 0 to 20, times 40, which is the height, gives you 400 meters. The area under the rectangle in section B from 20 to 40, so we're now looking at this rectangle here, so is 20 times 40, so that's the time in seconds. So we're looking for just this amount of time here, between 20 and 40. So 40 take away 20 gives us 20 seconds there, and then multiplied by 40, which is the velocity, it's the height of our rectangle. 20 times 40 gives you 800 meters. And so the total distance travelled we then work out by adding 800 to 400, so these two areas added together gives us the total distance travelled of 1,200 meters. Number 4, drag the correct answers into the boxes to answer the questions. So I've already done this. What is the velocity at 22 seconds? So at the time in seconds along the bottom here, so if we go up from 22 seconds, we can see that the velocity reading across directly between 4 and 6 is 5 meters per second. What is the acceleration between A and B? So here's A, here's B. The acceleration is by dividing the change in velocity, which is 10 meters per second from 0 to 10, by the change in time, which has gone from 0 to 5 seconds. So we work that out to be 10 divided by 5 gives us 2 meters per second squared. What is the acceleration between 5 and 10 seconds? So between 5 and 10 seconds the line is horizontal, so the velocity is stayed steady at 10, it's not changing, so 0 acceleration. What is the distance travelled between 0 and 5 seconds? So it's working out the area of this triangle here, which is a half times 5, which gives us 2.5, so a half times the base of the triangle, and the base of the triangle there is 5, times the height of the triangle, vertical or perpendicular height of the triangle, which is 10. So a half times 5 times 10 equals 25. Half times 5 is 2.5 times 10 is 25 meters, which you can see I've pulled into the box there. Number 5, the velocity time graph shows the journey of a cyclist on a road. What is the acceleration of the cyclist in the first 40 seconds? So acceleration is v, that's final velocity, remember, minus u, that's initial velocity, divided by t, that's time. So the first 40 seconds on here, we've got our final velocity at 40 seconds is reading across 8 meters per second. The initial velocity was 0, at 0 seconds. So 8 minus 0 gives us 8 divided by the time from 0 to 40 seconds. So 8 divided by 40 gives us 0.2. 8 divided by 40 gives us 0.2 meters per second squared. Don't forget the unit for acceleration is meters per second squared. B, what is the maximum velocity reached? That's 8 meters per second. We can see that where we've already highlighted. C, how far did the cyclist travel along the road in 60 seconds? So the area under the graph for the first 40 seconds, so we're looking at the area under the triangle here, is a half times the base, which is 40, times 8, which is the height, is 160 meters. Area under the graph for the last 20 seconds, so that's looking at this triangle here now, a half times the base, which is 20, 60 minus 40 gives us 20, times 8, which is the height, gives us 80 meters, and the total distance then is 80 plus 160 gives us 240 meters. Okay, moving on now to number 6. Type your answers into the boxes below. If a car took 8 seconds to increase its velocity from 8 to 28 meters per second, calculate its acceleration. So we've got v, our final velocity, minus u, our initial velocity. So that's v is 28 meters per second, u is 8. So v is final velocity, u is initial velocity. So 28 minus 8 divided by 8 is 20 divided by 8, which gives us 2.5. 20 divided by 8 gives us 2.5 meters per second squared. If a train accelerates uniformly, that means staying at the same acceleration from rest at 0.2 meters per second squared. So that's its acceleration there, which stays constant. That's what uniform means. Over 1 kilometer, so that's our distance, calculate its final velocity. Note s, that's the distance, is in kilometers. So use this equation, v squared minus u squared gives us equals 2 times acceleration times time. A for acceleration, sorry, s for distance, not time. So v is what we're trying to work out. U is at 0 meters per second as the train is at rest at the start. The acceleration they've given us up there is 0.2 meters per second, and the distance, s, not time, is 1,000 meters. So rearrange the equation to give v. So if we've got v squared minus u squared equals 2as, then we can rearrange that. V squared would be equal to 2as plus u squared. And then if we want to know v, we do the square root of both sides. So the square root of v squared is v, and then the square root of 2as plus u squared, which is what they've given us down here. V equals square root of 2as plus u squared. So v equals the square root of 2 times acceleration, which was 0.2 up here, remember, times 1,000, which was our distance there, so that's our s, plus 0, because u, the initial velocity, it says from rest, so the initial velocity is 0, so 0 squared is still just 0. So v is therefore the square root of 2 times 0.2 times 1,000 plus 0. So 0.2 times 1,000 is 400, and therefore the square root of 400 gives us 20 meters per second. So in summary, you've now completed all the math skills you need to interpret velocity time and distance time graphs. You should feel confident that you can calculate gradients from graphs and that you can rearrange and use the motion equation v squared minus u squared equals 2as. You should also be able to calculate the area under velocity time graphs to work out the distance travelled, and that bit is for higher tier only.